Could Earth become another Venus? It sounds like something straight out of science fiction, right? But the science behind this question is very, very real, and it has huge implications for our future. It forces us to look at our planetary neighbor not just as some distant, fiery ball, but as a potential warning. First, just look at this contrast. It's absolutely staggering. We live here on a planet with a comfortable average temperature of about 15 degrees Celsius. Venus, it's 462 degrees. That's hot enough to melt lead. Our atmosphere is this gentle, life-sustaining blanket. Theirs has the crushing pressure of being a kilometer underwater, and it's almost pure toxic carbon dioxide. So how on Earth did two planets, born so alike, end up so catastrophically different? And that question, well, it's really the heart of this whole story. It's a tale of two planetary twins, born at the same time from the same stuff in basically the same cosmic neighborhood. One became this perfect cradle for life, and the other became a vision of hell. And when I say twins, I mean it. The similarities are just incredible. Same age, same origin, they're almost exactly the same size, made of the same basic ingredients. And it's this deep, profound similarity that makes their differences today so shocking and so important for us to figure out. So let's do it. Let's conduct a kind of planetary autopsy. What exactly happened? What chain of events caused this total climate collapse? How did Venus go so horribly wrong? The answer, it turns out, lies in a devastating feedback loop that once it got started, just could not be stopped. Okay, so here's the recipe for disaster. Step 1, it started with its location. Being closer to the sun, Venus just got baked with way more heat. That intense heat began to evaporate its ancient oceans, turning liquid water into water vapor in the air. Now here's the kicker. Water vapor is a really powerful greenhouse gas. So, step 3, it trapped more heat, which, you guessed it, caused even more evaporation. High up in the atmosphere, solar radiation blasted these water molecules apart. The superlight hydrogen atoms just escaped into space, gone for good. And with no oceans left to absorb it, all the carbon dioxide from volcanoes just built up and built up and built up, creating the suffocating, superheated atmosphere it has today. This whole process, it has a name. It's called the Runaway greenhouse effect. And the most important thing to understand about it is this. It's a one-way street. Once a planet crosses this line, the warming just feeds on itself. It becomes an unstoppable force until the climate completely and irreversibly collapses. So the obvious question is, why didn't this happen to Earth? Well, as it turns out, our planet has some really powerful defenses. Think of it like a built-in climate thermostat that's kept things in balance for billions of years, allowing all of us to be here. Earth basically has three main protective shields. There's this incredible geological thermostat called the carbonate-silicate cycle. We have active plate tectonics, which Venus seems to be missing, and, of course, a powerful magnetic field that protects our atmosphere from getting blasted away by the sun. So how does this amazing geological thermostat actually work? It's brilliant, really. Over millions of years, CO2 from the air naturally dissolves in rainwater. This makes the rain slightly acidic, and it weathers down rocks on land. Those weathered minerals get washed into oceans, where eventually the carbon gets locked away into sediments like limestone on the seafloor. It basically pulls CO2 out of the air and buries it. It's this slow, steady, elegant balancing act. Now, Earth's natural defenses are incredibly powerful, but they operate on these huge geological timescales. We're talking millions of years. This brings us to the most critical question for us, right now. Can our own actions overwhelm these ancient systems and shove our planet down a similar path? When we dig into the science, we see that Earth really faces two potential paths to becoming a hothouse planet. One is this slow, natural, inevitable future measured in eons. The other is a rapid, self-inflicted crisis unfolding over mere centuries. Okay, so let's look at path number 1 first. This is the long game. This is the path Earth would be on anyway, even without us. A slow, natural evolution driven by the life cycle of our own sun. You see, as our sun gets older, it naturally gets brighter and hotter. Over hundreds of millions of years, that extra heat will eventually overwhelm our planet's thermostat. It'll trigger the exact same processes that doomed Venus. The oceans will eventually boil away, and Earth will become a sterile, scorching rock. But the key thing here is the timescale. We're talking about 1 billion or more years from now. But there's that other path, the one that operates on a terrifyingly faster timescale, the one we are on right now. We have pushed atmospheric CO2 from a stable 280 parts per million to over 420. That's a level our planet's climate system hasn't seen in millions of years, and we've done it in what amounts to a geological blink of an eye. This chart shows the reality of the situation. We are pumping CO2 into the atmosphere at a rate that is at least 100 times faster than those natural geological processes that Earth's thermostat is built to handle. We're simply overwhelming the system with sheer speed. And that speed is shoving us dangerously close to what scientists call tipping points. These are thresholds where, once you cross them, warming can become self-sustaining. Think about the Arctic. As the bright white ice that reflects sunlight disappears, it's replaced by dark ocean that absorbs heat. This absorbed heat melts more ice, which leads to more absorption. You see the vicious cycle. Now add in thawing permafrost releasing methane and a warmer atmosphere holding more water vapor, itself a greenhouse gas, and you've got the beginnings of the exact same runaway logic that consumed Venus. So what's the verdict? Will we literally become Venus? The science says no, probably not. To get to 462 degrees, you'd have to burn every last bit of fossil fuel on Earth, and then some. But honestly, that's the wrong question. The real warning from our sister planet is about something far more immediate and far more relevant to us. The danger isn't that Earth will become a literal clone of Venus. The real present threat is what some scientists call the Venus syndrome. This isn't a literal transformation, but an irreversible climate collapse that pushes our planet into a new, much hotter state, one that is fundamentally hostile to us on our timescale. So the warning from Venus isn't really about ending up with lead-melting temperatures. It's about tipping our own stable, precious climate into a chaotic and hostile state. A state that's governed by the same unstoppable physics that destroyed our planetary twin. Ultimately, Venus shows us where one particular road leads. The slow, natural one, well, that's an inevitability of deep time, billions of years away. But the other road, the rapid, self-inflicted one, that's a choice we are making right now. Venus is up there, a permanent, silent warning in our sky. The question is, are we listening?